check, 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 check. Okay. Good morning, everyone.
Good morning, sir.
Good morning. Yes. So, yeah, yesterday also we had a little bit of interaction, which was basically a revision for some of you. Yeah. So now I think today all of you are there. Very nice. Yeah. So we will start something new, which is called as skewness. It's actually in the different unit. So I hope from time to time you are going through your syllabus. I have your syllabus in Excel. I like to have these columns which are easy to maintain in Excel. So I have made it in Excel. Same syllabus which every one of you have. So in unit 1 we have seen the basic things. Most of it was yesterday. We can do some problems. We will be doing some problems. Basically, each of the types of charts you should have some practice of drawing. So I think one session we will keep as practice session. After we are done with skewness, so we are starting with the unit 3. As you can see, this is the unit 3. Yeah. Then after that, we will do, of course, unit 4. It wouldn't have harmed to start unit 4 and then come to unit 3. But as it is given, yeah, we can go by this sequence. Yeah. So we are starting with skewness. So what is skewness? What is skewness basically? For that, let us see frequency distribution we have discussed in the last class yesterday. Yeah. So if we plot frequency on one axis, and the variable you want to measure, say height of all of you. Yeah. In general, in naturally occurring phenomena and in many man-made phenomena, human endeavors, which we call them. So the graph follows a bell shape, frequency on one axis, and the variable we want to measure if there are many number of data points. I think there is some signature. Just a second. There is some notice. She won't get through. आज का ना ठीक है, थैंक यू। कल से करने के उसी में करना है, कल से उसी में करना है। हाँ हाँ, yes, so we can continue. Yes, so on one axis frequency, y-axis frequency, and the other axis it is variable. So that distraction, I know variation, variable. Yeah, any variable we want to measure. So maybe height, maybe weight, maybe anything else. And if the data is large, data points are large. Yeah, 1,000, 10,000. Yeah, in 10 data points, we cannot say that the graph will have a particular shape, which we can predict in advance. But if we have large data points, large number of data points, 1,000, 10,000, yeah, and statisticians handle that kind of data. They take the pains to collect that amount of data, and then they do their analysis. It is their science. It is actually it could be your science, it could be my science. When we pursue it for long enough, say 1 year, 2 year, 3 year, then it becomes our field also. Yeah. When statisticians do that, frequency versus variable, most phenomena have this kind of bell-shaped curve. L-shaped symmetrical curve. Yeah. So here there will be all the values. Say if it is weight, so 40 kg, 42 kg, 44 kg, like that. All the weights will be here. And near the center, we will find that the mean of all the values is near the center. Yeah. And this peak, ये जो ऊपर का शिखर है, peak, this peak will correspond to the mean. Of course, we are talking about frequency and probability. So yeah, we have to keep that in mind. So this peak will correspond to the mean in a symmetrical data. Yes, in a symmetrical data or data which has a symmetrical graph. Okay, now this is symmetrical. But always we won't get such a symmetrical graph. Yeah. Sometimes it could be different. Sometimes it could be below this. Yeah. Sometimes we will have a graph which looks like this. Same axis, frequency and the variable we are considering. Sometimes it will be like this. Yeah. So this portion is heavy. You can say this portion is heavy. This portion also looks like a tail. Yeah. Isn't it? It looks like a tail. Okay. This is one case. Yeah. And the other case you can see, or the other case you can find, looks something like this. So now this tail is here on this side. Axis is same. Everywhere it is frequency. Frequency in turn becomes probability. Yes. When there is a large data, frequency over time tends to become probability. When there is nothing else to find out the probability, we convert frequency into probability. So frequency probability भाई है, अब याद रखिए, they are very much related. Yeah. So now considering these graphs, here this first one is symmetrical. Yeah. The second one has its tail to the right side, of this peak. शिखर के right वाले भाग में tail है, and here the tail is on the left side. Okay. This is called skewness. This peak not being at the center and the graph not being symmetrical is called skewness. This is called a right skewed graph. Right skewed. And this is called a left skewed.
Excuse me, sir.
Yes.
Can you explain what skewness is again?
Yes. Skewness is the property of frequency distribution graph not being symmetrical. Yeah. It is inclined to one side. This is a frequency distribution graph. All these are frequency distribution graph. The first one is symmetrical. Yes. And the other two are not symmetrical. So the property of frequency distribution graph not being symmetrical is skewness. When it is not symmetrical, it is naturally inclined to one of the sides, either right side or left side. When the tail is towards the right, it is called right skewed graph. When the tail is towards the left, it is called left skewed graph. Okay. All right. This much is clear. Skewness.
Yes, sir.
Yeah. Skewness definition. What is skewness? Okay. So now we go a little deeper. So this is we discuss that the mean will be at the center corresponding to the peak, yeah, or yeah, peak of the graph. Now in a symmetrical graph, not only the mean, but this very point will also correspond to the median also in a symmetrical graph. From the data, we will not be able to make out. By looking at the data, we will not be able to make out. Iska graph symmetrical banega. We have to draw the graph. Yeah, and maybe by practice over some time, you'll be able to make out whether it's a symmetrical data or skewed data. Yeah, but initially we should not even try to guess from just looking at the data. We should draw a graph, and that will be more robust. It will eventually clarify things. So not only this point will correspond to the mean, it will also correspond to the median, and it will also correspond to the mode. Yeah, mode is of course the highest frequency point. Mode, yeah, mode is apparent. Mean and median will also be the same point. The same. Yeah, if it is weight, and say this for your class, say it is I don't know 55 or 65. My weight would be of course almost much higher than this. Yeah. Faculty's weight will be much higher than this, let us say. Yeah. But your weights will be somewhere in that range. Mean will be in that range, 55 to 65. Yeah. This is the case of symmetrical graph. But in case of skewed graph, skewed data, of course, mode will correspond to the highest point. There is no doubt about it. Yeah, frequency सबसे ज़्यादा है, so this point will correspond to the mode. Yes. Here also, the peak will definitely correspond to the mode. Almost by definition, this data की सबसे ज़्यादा frequency है, that we call as mode, right? So the peak in even in skewed graph will correspond to the mode. Now the question comes, where will be the mean and median in these two cases, in the skewed cases? Yeah. So I would like to put it as a challenge, mini challenge. So, yeah. So take a minute, take 1 minute, and try to find out, try to logically reason where should be the mean in this case, right skewed graph. Where should be the mean in this case, in the case of left skewed graph? So take a minute. I will stop talking for a minute. So you can discuss. You can use this forum only. Use the Zoom forum only to discuss if you want to discuss, and then we will discuss the answers, different answers. Yes. So what do everybody think? In this case, in right skewed graph, where will be the mean with respect to mode? Mode we have drawn already. Where will be the mean? Towards right or towards the left?
So which graph are you talking about, for the right one or the left skewed graph?
Yes, for the right graph. Right. For the right skewed graph, which is on the left. Sorry. Okay, I should keep that in mind. The right skewed graph we have drawn on the left. Yeah. So this left one, which is right skewed. Mean will be here somewhere or here somewhere. It will be here or it will be here somewhere.
So I think the mean and median will be opposite to each other, but I don't know where to put them first. Like I don't know where the mean will come first, and then opposite to that will be the median.
Okay, so you can try to reason logically. Of course, from the data we do not have the data in front of us, so we can only reason logically where will be the mean. See, the logic is here in this case, uh, less data points are on the left of this peak. Less data points are on the left of this peak. Yeah. So the mean, which is like the central data point, which will be pushed towards the right, which will be automatically pushed towards the right, rather than on this side, left side of the mode, it will be on the right side. Yeah, because there are more data points here, and mean represents, say, the majority of the data. What is the value of majority of the data? So when more data is towards the right of this peak, mean will be towards the right of this peak and towards the right of more. So in this case, right skewed data, mean will be here towards the right. Yeah. Exact position will depend on the data given, but this will be like this always. In a right skewed graph, yeah, the mean will be towards the right of more. Similarly, by similar logic, in this case, left skewed graph, the mean will be towards the left of more. Because here on this side, there is more data. On the left side, there is more data points. Only a small number of data points are towards the right of this mode. So mean, which is a representation of the data, representation of the majority of data or the central data point, so to say, it will tend to be on the left side because there are more data points on the left. So that is the logic. So mean will be towards left of the mode in left skewed data. Mean will be towards the right of the mode in the right skewed graph, right skewed data. Now comes median. Where will be the median? Now, coincidentally, in both the cases, median will be between mode and mean. So somewhere here will be the median in this case, and somewhere here in between mode and mean will be the median in this case. So this is the position of mean, median, and mode in left skewed and right skewed this is a area where many people tend to forget, many people tend to get confused, starting with the definition of which one is right skewed, which one is left skewed. Yeah. So जहाँ पे tail है, wherever the tail is, that is the name of the graph. That gives the name of the graph. If the tail is towards the right, it is right skewed. There should not be any confusion in this. Yeah. And with respect to mean, median, mode, mode is always apparent. Yeah. When there is a mode, it is always apparent. It will correspond to the peak. Then in right skewed, mean will be towards the right of mode, and in left skewed, mean will be towards the left of the mode. And median will be between mode and mean in both the cases. Mode and mean in both the cases. Between mode and mean in both the cases. That will be the position of median. So now going forward, now this is conceptually we have understood what is skewness, and most of the times we want to have a number, numerical representation. So if we have two right skewed graph, say two right skewed graph, which one is more skewed? How will we pass on that information easily? Yeah. Rather than drawing the graph and trying to convey the graph every time, wouldn't it be better to have a number representing the extent of skewness or measure of skewness? So we have that. We have that measure of. There are a couple of ways to measure skewness, and all three we will discuss three ways. All three are almost equally popular. The first one is more robust, statistically more robust, or logically more robust, we can say. The other two are also good measures of skewness. They help you compare graphs. Yeah, they help you compare graphs. Which one is more skewed? Which one is less skewed? Now let us let us use the first method to measure skewness, which you can call the basic moments formula. Moments. Measures. So the first one is basic moments formula. So now pay attention. It looks somewhat like this. It basically originates from this basic form. So we'll have a look at that. So it originates from this. The modification of this turns out to be like this. Divided by standard deviation and 1 by n. So this is the formula for skewness. When we study kurtosis, you will see there is a resemblance in the structure of the formula there to measure kurtosis also. The structure is very similar, very much similar. So here it is summation of xi minus x bar whole cube divided by standard deviation of the data whole cube of that and multiplied by 1 by n. This gives a robust measure of skewness. That's extra high. Should not cause any confusion. Summation sign. So this is the measure of skewness. You can see there is some resemblance. There is some resemblance with this formula to the standard deviation variance formula. Do you remember the variance formula? So this is the formula for variance. So variance is many times called the second moment because the exponent here is 2. It is called the second moment. By the same logic, skewness is called the third moment of the data. Third moment of the data. Moment, if you want, we can discuss separately in some session. So here we are focusing on skewness. So just the definition of moment. So this is the second moment, which is our very old friend variance, and skewness is the third moment. Exponent here is 3, and a little modification of this formula gives us this summation of xi minus x bar whole cube divided by standard deviation cube multiplied by 1 by n. Okay. So this is So with any data, you can try to find out the skewness of that data. Any data we have discussed so far, like last time we had a data. Yeah. See, for this data also you can calculate skewness. The first data set we used temperature and cooling. In any of the other data set also, you can calculate the skewness. Right. And something we used last time. Yeah, yes. For this data also, you can calculate the skewness, how skewed it is, or whether it is symmetric. Yeah. So this way you can calculate the skewness. This is actually the most robust way. Basic moments formula is the most robust way. Then how will you infer? Now if skewness is 0, this is an important slide. If skewness is 0, that means the graph is symmetrical. Yeah, graph will has So in the symmetrical graph, skewness will be 0. Now, if it is little bit skewed, it will be 0.5, like this, a little bit skewed. This is towards the right. So skewness, when you calculate skewness, will come to be positive. Yeah, that is also a very important point. Please make it. When skewness is positive, that means it is right skewed graph. When skewness is negative, it can be negative also because Yeah, in the formula it is Q. So Q can be negative and positive both. If the number is negative inside this bracket, that will be negative. Q will be negative. If the number is positive, Q will be positive. Not like variance. Here all the data will be positive. Variance will always be positive. Because square of every number is positive. There is no scope for it to be negative. But here skewness can be negative, can be positive. If it is positive, that means it is a graph like this. Right skewed graph. If skewness comes out to be negative, that means it is a graph like this. Yeah, left skewed graph. Alright. So now coming back to that important slide. Yeah. Skewness 1, that means it is very much visibly skewed. And more than 1, it is very highly skewed. Yeah. More than 1 is almost on one side. So looking at the graph, you can have a rough estimation of the skewness. Now that you know, yeah, symmetrical graph, you know that skewness will be 0. A little skewed, पता ही नहीं चल रहा है skewed है नहीं है. So and also it is not looking symmetrical. So it will be more likely in the range of 0 to 0.5. If it is visibly apparent, it will be almost 1, near 1. And if it is like this, बिल्कुल झुका ही हुआ है एक तरफ, very apparent, so it will be more than 1. Skewness will be more than 1. So you know the range of values you are going to get. You are unlikely to get skewness as 100 or minus 100. So you will get in the range of 0 to 1.5, 0 to 2, like that. So this is the basic calculation of skewness, how the graph looks like for different values of skewness, 0, 0.5, 1, 1.5. We just saw this graph, these graphs. Yes. Now moving on to a little bit simpler formulae, which are also popular, almost equally popular as I said in the beginning. So one is Pearson's formula for skewness. Yeah. Now Pearson is was a very great statistician. He has worked on very many different concepts. You have Pearson's correlation also. So when you're using something, be very careful whether it is which concept it is. Pearson's correlation coefficient or Pearson's skewness calculation, skewness coefficient. So Pearson's skewness coefficient. So this basically uses mean and median. Mean and median. I'll write down the formula. It is very simple. So P multiplied by mean minus median divided by the standard deviation. This also gives values which are in that range. For different cases, the range of values given by this simpler formula is also same, almost same. So this is the Pearson's skewness coefficient. Very simple. 3 multiplied by mean minus median divided by standard deviation of the data. So given any data set, first we calculate the mean and standard deviation. So mean and standard deviation will have given any data set, and they are very easy to calculate. Now the only additional thing for this formula we have to calculate is the median. Actually, there is a version of this formula with mode also, but I will suggest not to use that because in many data points, in many data sets, there may not be a mode. Mode basically means what? The most frequently occurring data. But mode may not be present in every data set. Considering your heights, there will be a mean, there will be a median, but there may not be a single height, say 5 feet 6 inches, with much more number of people in that height. There may be, there may not be. Yeah, so mode is a little tricky. Mode may not exist for all data sets. If everybody's height is different, suppose in the case everybody's height is different, there may not be a mode because there is no data for which frequency is more than others. So mode may exist, may not exist. Yes, I think there is a doubt.
Yes, sir.
Yes, yes.
So, can we use any formula, or are we supposed to use formula depending on the question?
Yeah, depending on the data available. If individual data points are given, the first one, basic moments formula, is the best one to use, and it will give most precise data. But suppose raw data is not available to you. Yeah, many times it can happen. You're taking data from, say, some research paper or some secondary data source where you do not have access to raw data. But the researcher calculated mean, median, mode, standard deviation, those things you have. Yeah, so then you can very easily use Pearson's skewness coefficient. Yes.
Okay, sir.
Yeah. So these are the. This is the second method. There is also a third method. I think, but before that, we should try to correlate this with the concept of box plot. Now coming back to box plot. If you want, you can again take a half a minute relaxation time so that you are able to absorb, and we will relate this concept of skewness and box plot. So yeah, it is good to have these short breaks. You can have deep breaths. We are studying math, statistics, very intense subjects, very nice subjects, useful everywhere, and at the same time intense subjects. So you can take a half-a-minute break. Now it's 12:13, 12:12. We'll again start at 12:13. Okay, all right. Let us restart. Yeah. So skewness and box plot. Box plot, you remember how do we draw box plot? Yeah. Say horizontal box plot. Looks something like this. So here we won't have actually anything on the axis. Here the variable will be on the x-axis, and we will have a box. This will be the first quartile. Quartile, I hope you remember. First quartile. Then at the end, there will be the third quartile. and the second quartile will be somewhere here, okay, depending on the data, somewhere here. And there will be whiskers also. Calculate the end of the whiskers. We use the formula. We use a formula which I hope you'll be able to recollect, or maybe after revision today you'll be able to recollect. So this is how a box plot looks like. This is the first quartile, this is the second quartile somewhere in between, and this is the third quartile. Now skewness has an effect on the box plot. So if the data is right skewed, it will look exactly like the box plot we have drawn. Yeah, coincidentally we have drawn this part from Q2 to Q3 as larger. So if the data is right skewed, the box plot will look like this. This portion, the right portion of the box, you can say, will be larger. Or the right whisker will be larger. Here, the way I have drawn, both are there. But if any of this is there, it is a right skewed data. From the box plot itself, you can infer, you can find out that it is a right skewed data. The raw data is right skewed. When this right part is more, or this whisker, this whisker, right whisker is longer, then it is a right skewed data. Similarly, you can guess what will happen in left skewed data. Again, there is a we can draw a box plot. Here, in this case, this will be Q1, this will be Q3. But if the data is left skewed, then the left portion will be much bigger. Or the left whisker will be much bigger. The whiskers can be equal also. This is one case where the whiskers are almost equal. This can be also the case. Then also it is left skewed. Or it could be that the left whisker is much longer than the right whisker. The length of only whisker can also determine. Yeah. So suppose, I hope you understood so far. Let me draw a question graph. Yeah. So now this is the case here. Which will actually really happen. So now tell me whether this belongs to a left skewed data or right skewed data.
So right skewed. Should be, like the right side is a bit longer. Or if it's the same, then it's the symmetrical graph.
Yeah, I have tried to draw this in the middle actually. Yes. So this is almost in the middle. Q2 is almost in the middle. Okay. Now only the length of the whisker can also determine whether it is left skewed or right skewed. Here it is definitely left skewed because this is much longer. Whisker is much longer. Yeah. So this is the relationship between a very nice, interesting relationship between box plot and skewness. Yeah, I hope you enjoyed this.
So how does the question on this topic come about?
Question will depend on the understanding. I mean, if you have understood, you can answer any question, right? So,
but so what will be the format of the question?
Format, some data will be given, and based on that, all questions will be asked whether the data is right skewed, left skewed, or two data sets will be given. You will be asked which is more skewed. Yeah, then you have to calculate skewness for both and compare which is higher. Yeah. And maybe in smaller question, objective question, you will be given a value of skewness minus 1.25. So you will be asked whether it is left skewed or right skewed. So as it is minus, it is left skewed. Yeah. Then yeah. So depending on the concept, questions like this can be formulated. You can formulate n number of questions and give each other. If suppose this happens, suppose आप questions बनाते हो एक दूसरे को देते हो, then if the questions are good, we can have at least some questions from your pool, your created questions in the exam also. If the questions are good and all of you have understood that, yeah, that can also happen. So don't worry about too much about questions. Of course, yeah, you should have some idea. Yeah, whenever we learn some concepts, we also tend to think how it can be applied in real life, how for some
So you're
certification,
lagging.
good certification, then we are also. Yeah, so I'm saying, yeah, if the concept is clear, you will be able to answer any question. That's what I'm saying. Check, audible? Okay. Okay. So now the third formula we are going to use is called Pauli's formula. For skills. I am audible, right?
Yeah, sure.
So this is also a very simple formula. So what it says is it uses Q1, Q2, Q3. That's why we discussed before this, the box plot concept before this. Yeah. So it says Q1 plus Q3. Okay, let me pose it as a question. Let me pose it as a question. In the box plot, you want to find out the extent to which Q2 is in the middle. By now, Q2 you have realized what is Q2, other good name for Q2, you have already answered in the previous class. Q2 is also the median, the exact middle value. Yeah. So if you want to find out to what extent Q2 is in the middle of this box plot, you want to find a measure of that, what you will do. We have some time, again, take a break and I'm posing this question. After that, we will discuss the formula. Then I hope you will appreciate the formula, or you will not require the formula anymore because, yeah, it's valid. You want to find out to what extent it is in the middle, Q2 is in the middle. You should be able to compare two box plots. Okay. Yeah. Maybe this is not something generally we can figure out in a minute or two, but at least you're thinking in that direction. Some of you may have got something. Would you like to share? Anybody? Okay. All right. No sure. What is the format? Yeah. So someone who have understood how to find out Q1, Q2, and Q3, please explain to your friends in the evening today. Please do that, or we will discuss again in the next session. So here, it is very easy actually. I think they will also. Yeah, Vedant. Yeah, it's simple. Just try today evening. Otherwise, we will again discuss. So, Bowday's formula. Now, look at this formula. 1 plus b minus this itself will give a measure what extent Q2 is in the middle. Still, to make it even more robust, we have this difference also. This is Bowday's formula for schemas. Look at the numerator. If Q is exactly at the center, you will see that numerator becomes 0. And that is how it should be. Skewness of a symmetrical graph. In a symmetrical graph, Q2 is exactly in the middle. So Q1 plus Q3, you can try to do all kinds of calculations. So this is Q1 and this is Q3 and 2Q2. That means twice you are taking Q2. Twice you are taking Q2. And when you are subtracting these two parts, this part and this part, this part, what essentially you are doing till Q1, it is common everywhere. So what we so this will be twice here and also twice here. So what we are trying to measure is comparison of this distance between Q3 and Q1, this distance, how long it is compared to this distance from Q1 to Q2. If it is exactly in the middle, this distance will be twice this distance from Q1 to Q2. The distance it will be from Q3 to Q1. The distance, this distance will be twice this distance if Q2 is exactly in the middle. And depending on whether it is towards the right or whether it is towards the left, these will give a measure of how skewed the data is. Basically, we are trying to measure what extent Q2 is in the middle or not. What extent Q2 is in the middle or away from the middle. So, yeah. So have a look at it again. Maybe this was a slightly complicated formula for QNS. At least the logic was complicated. Once you know Q1, Q2, Q3, how to find Q1, Q2, Q3. This could also be the simplest formula. So this is one. Alright, so in today's class, we will end today's class here. I think one problem will do good. It will clarify a few things and it will give you some practice, which is very important. Otherwise, even if we understand, maybe after a month, it won't be there. We won't be able to apply when required. So we'll do one or two problems. Yeah. For today, we are ending here. If you have some doubts, I think there are some doubts. There should be some doubts. We will also discuss those in the next session. That is next week. So have a nice weekend. Yeah. And we will meet again soon.
Thank you, sir.
Thank
I
you.
understand.
Thank you.